11 through 16, you did not have to give me a reason. You just had to set up write the equation and solve for x. You had to know the relationship between those angles. So the values for the variable are in red. This is the part of number 17 I was looking for. Okay, any questions on the KWS assignment? Any questions on the KWS assignment? No? Okay, let's do the 3-3. I'm going to put these up. Do a check. All right, so scrolling 4, 5, 6. Seven. We are doing 8. I don't have an answer key there for it, but if you're not sure about 8, we can do that one together. I don't have the answer for that one off the top of my head. I haven't worked it yet, but let me know if you want me to work that one. I will. Bless you. Yep, you're just finding the value of x. So you did have to write an equation. That writing the equation will show me that you know the relationship between the angle pairs. So you're supposed to tell which lines of each of these angles can be used, or pairs of angles can be used to prove a particular lines are parallel. For example, 15 says you're starting with the angle. These two angles are supplementary. Since it tells you that they're supplementary, we should be able to see that those are same side interior angles. And by definition, if the lines that create those that are crossed by transversal or parallel, then they'd be supplementary. So that's how we know T and U is parallel TU are the lines that are crossed by the transversal B. Anybody have any questions on those? And the last two. They all needed work or justification. Any questions on the 3-3 worksheet? Okay, I did grade your tests. They are in focus. If your test grading is higher than your quiz rate grade, I replaced it. I replaced rather the quiz grade with your test grade. They were a little bit better than the quiz grade. I would not say a whole lot better, but they were a little better on average than the mid-chapter quiz grades were, so that's good. Some people really pulled up their test grades, so it really helps them a lot when you get to replace 35 with 2 80s, right? So that's very helpful. All right, if we don't have any questions on anything from 3-2 or 3-3, so our KWS is from section 3-2 and 3-3, and the worksheet yesterday was from 3-3 alone. No, we're getting ready to start notes, Thomas. Is it an emergency? Oh, that's not what I wanted. Oh, is it? Let's see. Okay. So today we are talking about slopes of parallel and perpendicular lines. Parallel lines are an algebra benchmark. You guys should have been working it. Oh, you don't have those yet. I printed them, and I forgot to staple them, and so I didn't want you guys to graduate your face. Stop having me knocked around. Thank you, Elizabeth. The look of confusion on your face would you have to tell me I forgot to pass it out. You can staple them on top of that, staple back column. You would staple yours and pass the staple back in here. Yeah, it's just print. That's the way it's printed. You just have to turn them around when you do it. It was in order unless you change the order. Yeah, it's in order. Because it's stapling and you can flip it the way you need to flip it when we take it out. I don't know what some of them. So if you flip them, just flip them up and fold it over, Diggory. They won't be upside down. Okay, parallel lines. Algebra benchmark, you guys have been working with parallel lines since 7th grade. We talked about parallel lines with regard to parallel lines being crossed by transversal. You need something? You what? What's wrong? The first page? Did you pass something back? Okay, you were supposed to pass something back. So if Elizabeth passes something back, you're not supposed to have it. I have them put together. But here, compare it with that. This is the picture you want to confusion, okay? What's that? Nobody need a pencil. I don't mind a pen on the vocabulary, but whenever we're working from, it has to always be a pencil. Even if you're perfect, I am not. I'm going to mess something up, and you're going to have to replace it or erase it. So, do you have a pencil? Okay, let's use a pencil. All right, parallel lines, perpendicular lines. We're concerned with the slope of these lines. We have been working with parallel lines already this year. You guys remember what parallel lines have in common? What do any parallel lines have in common? Bigger? Well, lines are infinite, right? We don't measure them, right? What does it mean to be parallel? Tells us they never intersect, right? Yes, because we're talking about the specific slope. Parallel lines have to have the same slope. Right? So you can have two lines with the same slope, they're parallel. Four lines with the same slope, they're all parallel, right? So that's what we're talking about. We're going to fill in here. This is a little bit wordy. You can just write have the same slope, but different lines intersect. There, you get something to write with? Perpendicular lines. If you are an algebra and honors, you might have encountered how we know that two lines are perpendicular based on their slope. Does anybody remember talking about perpendicular lines and the relationship between their slopes? Perpendicular lines have opposite reciprocal slopes. That means opposite sides, and you flip the fraction. Okay? So you can just write, let's write the first part. Reciprocal lines have opposite reciprocal slopes. I do want you to write, change the sign and flip it. We're going to do examples so you'll know what that means. We mean flip the fraction. So looking at those examples, says, for example 1, we're looking at a line that has a slope of -4. Remember, m is what we use to represent the slope of a line. So m, when we're working with slope-intercept form, is y equals mx plus b. So if we have a line and its slope is -4, what would be the slope of a line that's parallel to it? Let's make a note here. P is going to represent the word parallel. And that upside down T is going to represent the word perpendicular. So this would be what is parallel to this slope here. Figure 4. No, not 4. Same slope, right? This slope is -4, so we need the same slope. So if this line has a slope of -4, and we want a line that's parallel to it, right? We're talking parallel right now, right? Oh, parallel. Yeah, parallel, same slope, right? So this line is the slope of -4. What's the slope of a line that's parallel to it? Yes, -4. too easy. Sometimes it's too easy and makes it more confusing, right? Specifically, you'll see that definition for parallel lines. So the same slope, but different y-intercepts. So they're going to cross a coordinate plane at different points. So if you look at this coordinate plane here, I actually did it for like a different class, but this line crosses has a y-intercept of 30 on the y-axis, right? And use your imagination and pretend that those are parallel and they kind of squiggly. So we're going to say these are parallel, so we know they have the same slope. And this one has a y-intercept of 10. If they have the same y-intercept, they would be the same line. Does that make sense? Graphing the line on top of the other line. Okay. So now perpendicular. So if we've got a slope, a line has a slope of -4, and we want a line that's perpendicular to it. If our given slope to that line is not a fraction, it's a good idea to go ahead and write it as a fraction. How can we rewrite -4 as a fraction? Ready? Elizabeth? What'd you say? You could do -12/3, but then we have to simplify it again, so let's just simplify one, right? You're exactly right. That's what you could write any form of that, but then we have to simplify it again. So let's just write it -4/1. These are the same slope here. So opposite is what we're looking at now. So if this is the negative, our slope is going to be the opposite sign. So whatever the sign is, we change it. If it's negative, we change it to positive. If it's positive, we change it to negative. This was a negative, so we're going to change it to a positive, which means I'm not going to have anything when I slide this little box over. There's no negative sign there. Now, reciprocal means flip that fraction. That's going to be 1/4. No longer positive, no longer negative, and we flip it around. So if the slope of a different line is 2/3, so this slope is, 3/7. What is the slope of a line that is parallel to that line? Ashton says 3/7. Ashton is right. What is the slope of a line that's perpendicular to this line? Think. Divided? Right. So if it's a positive, now we're going to change it to a negative. Let's change the sign and then flip it. Put the numerator where the denominator is, the denominator where the numerator is. So the last example is a little bit of a trick question. So if the slope of the line we're referring to is 0, what is the slope of a line that's parallel to it? 0. That's the same, right? This is the tricky part. So for opposite reciprocal, well, what's the opposite? Does 0 have a sign? No. Now, and if we just rewrite 0 as a fraction, and then we flip it, what do we get? No, we get it undefined, remember? So, example 3 is related to this statement here. Vertical and the horizontal lines are perpendicular to one another. So, x-only lines are vertical lines. So, a vertical line, straight up and down line, its slope is undefined. Y-only lines of 3 is a horizontal line. So a y only line, that means when you see the equation, it only has a y. They are horizontal lines. Horizontal lines always have a slope of 0. So if you can't do opposite reciprocal, you should remember that. Start here, undefined. I'll finish the word. Slope of a vertical line is undefined. The slope of a horizontal line is 0. Today's lesson, we're going to be, maybe I'll take that in the way I class. Today we're going to be looking at lines and put your phone out of your pocket. Put your backpack down and make sure we're following along, okay? Yes, we're going to be using these rules, these relationships, and determining whether certain lines are parallel, are they perpendicular, or are they neither parallel or perpendicular. If the line slopes aren't the same, then they're not parallel. If they're not opposite reciprocals, which would make them perpendicular, then they'd be neither, right? So, here we go. The first thing we need to know, remember, is the slope formula. The slope formula is the change in y divided by the change in x's. Most people like to see it as y2 minus y1 divided by x sub 2 minus x sub 1. Really, the subscripts aren't that important. The important part is that you keep the ordered pairs together from top and bottom. So for this example, we want to find the slope of segment AB. We're going to plug it into this formula. To the y minus y, remember, ordered pairs, x and y, x and y. So y 2 minus negative 4 over negative 1 minus negative 4. The important thing is you see this ordered pair, negative 1 and 2, they're lined up on top of one, the y over the x. So the ordered pair has to be lined up. It does not matter which one you put first. We could have put negative 4 minus 2 on top as well. That part doesn't matter as long as you keep the ordered pairs matched up on top and bottom. If you do this straight across on your calculator, you're going to get, let's do that right, 2 minus negative 4. So that's going to be plus 2 plus 4 is 6. And then negative 1 minus negative 4. So that's going to be a plus, so that's going to be positive 3. And your calculator will do this for you. I know for some of you this is a lot. But remember, your calculator will do this for you if you put it in parentheses and use the ABC button. 2 minus 4 negative button, put all that in parentheses, ABC, left parentheses, 1 negative button minus 4 negative button in parentheses. It'll do all that for you. And it'll just take you straight to 2. You don't even have to have that step in there to use your calculator. So the slope of segment AB is 2. We go down to B. It says find the slope of a line that's parallel to AB. Remember, the P means parallel. So what was the slope of a line that's parallel to segment AB? AB? All right, well, let's look back at our definition real quick. Parallel lines have the same slope. Okay? So if we have a line that has a slope of 2, what's the same as 2? 2. That's all. So the slope of a line that's parallel to segment AB is 2. How? 2 to 2? This word means parallel to segment AB. Remember we wrote that the P, big P stands for parallel? Right. So the question is, find the slope of a line parallel to segment AB. And AB is 2. The slope of AB is 2. Right? So we can write that there, but make it clearer for you. But n equals 2. So what is the slope of a line that's perpendicular to AB? Well, if AB's slope is 2, we're going to write that as a fraction. So let's always make it the easiest possible fraction. Just put it over 1. Okay? So anybody want to take a shot? What is the slope of a line that's perpendicular to a slope of 2? Ashley? Perfect. This one is positive, so now it's going to be a negative, and it's 2 over 1, so we just flip that fraction around, 1 over 2. So to give you 2 points, and you need to find the slope of the line that goes through those 2 points of this segment, then you can use the slope formula. If they give you the graph of a line and show you the points on there, do you guys remember how to find the slope of that line from a graph? We could use this, but there's a little bit easier way you can remember how to do it. Anybody remember? We can use the rise over the run. So the rise is the change in y divided by, and then the run is the change in x's. The rise is up or down, run is left or right. So we're looking here for the slope of the line that goes through these 2 points. So this line doesn't only go through these 2 points, right? This line goes through this point, it's an infinite number of points. When we use the strategy to find the slope of a line from a graph, we want to look at points that cross at these nice neat intersections of lines. We're going to use vertices here. So this point crosses nice and neatly. This one crosses nice and neatly. So if we're using line over run, all we have to do is count from one point to another point. So we're going to go straight up or down, depending on which point we want to start with. I can start with the top one, or I can start with the bottom one. If I start with the top button, I'm looking at here. I said button. I mean the top point. How far do I go down until I'm even with the other point? So that is our rise. So we're going to count 1, 2, 3. Here, what kind of 1, 2, 3, 4, 5, 6. I got 6. Is that what y'all got? All right, and we went down, so you have to remember going down on the coordinate plane is a negative 6. It's negative, so we went down 6, so that rise is negative 6. And then once we're even with that point, now we're finding our run. And that means how far do we go left or right? Well, we go right, 1, 2, 3, 4, right? If we are right, or that's positive. So right on the coordinate is positive, left is negative. Down on the coordinate is negative, up is positive. So now we have this slope. If you put this in your calculator, it will simplify it for you, but the slope of this line that goes to those 2 points is negative 3 halves. Okay? Adine, what is the slope of a line that's parallel to this line? And so remember, over here, this slope is 2. You said it was the same, right, buddy? So the parallel line would have a slope of 2 as well. If this slope is negative 3 halves, what is this one going to be? Yeah, -3/2. That's all it's going to be. Nothing trickier than that. All right, now we're going to find the slope of a line that's perpendicular to this line. So we need opposite reciprocal slopes, right? Vivian, you want to give it a whirl? Positive 2/3, that's exactly right. Change the sign, so it's going to be a positive, and we flip the fraction, so it's just 2/3. Okay. So now we're going to use all that to determine, are these segments that they're giving us, are they parallel, perpendicular, or neither parallel or perpendicular? If they don't have the same slope, and they're not opposite reciprocal, so we say they're neither. All right? So for finding, if this says our segment FG and segment HJ, parallel, perpendicular, or neither. So all we can do is find the slope of each of these segments and then compare them. So FG is found by using the order pairs for the two endpoints, 4, 2, and 6, -3. So we're going to plug in to the formula. So I'm going to do 2 minus -3 over 4 minus 6. So I did the first one minus the second one. Remember, that order doesn't matter. I just have to keep my order pairs lined up, and you'll see that 4, 2 is first. 4, 2, 6, -3 is second. So if you do that on your calculator, you're going to see that it is 2 minus -3 is 5, 4 minus 6 is -2, right? So it's -5/2. Any questions about how to find the slope of that segment? So go ahead and find the slope of HG. HJ, thank you. HJ. So H is the endpoint here. Remember, these all are X and Y coordinates, right? X is always first, Y is always second. That's where we're getting our values to plug into our formula. So for HJ, I start with the Y minus Y over X minus X. So that's -5 over 2. And you can put that in your calculator, it will do it for you. So are they the same? Are they opposite reciprocals? Or are they neither of those? Are they the same? So are they parallel, perpendicular, or neither? Parallel. And you find them by, you do this problem by finding the slopes and comparing. You don't have to write that part if you don't want to. I don't think I covered that for everybody today, but that's how we did it. Okay? Any questions on that? All right, I think it's just 7. We'll come back to that if we have time. All right. So are these lines parallel, perpendicular, or neither? Now we're not using the formula. We're not using rise over run. We're using linear equations written in a certain form. Easiest form to recognize the slope is slope-intercept form, where the number being multiplied by the x is the slope. That's only if you have the y isolated. So for this example, what is the slope of this first line? So remember, these equations represent a line. They're linear equations. So if you graph them, you get a line. So what is the slope of this line, Miles? Sorry? 1/3, yes. So the number being multiplied by the x is 1/3, so that's the slope. Problem here with number 8 is this is not the slope-intercept form. So before we can identify the slope, we got to get y by itself. So I'm going to come over here, and I'm going to isolate y. I'm going to subtract 2x from both sides, but then you can get rid of the whole thing. And what I have left here is negative 6y equals negative 2x minus 5. Now to get y by itself, I need to divide everything by negative 6. And so that leaves me y equals negative 2 divided by negative 6, that's 1/3. X plus 5/6. If negative divided by negative is a positive. So now, what is the slope of this line, Carlin? This line is the same as that one. So what is the slope of this line? What's the multiply? Sorry? I did rewrite it. So this is the equation. So which value in here is the slope? There's only two numbers. Is it 1/3 or is it 5/6? Remember? Yeah, 1/3 or whatever number is being multiplied by the x is the slope. So this is 1/3 times x, so the slope of this line is 1/3. They are parallel. So you don't have to write this part if you want. Don't want to, but that is the strategy here. Solve for y to get a both written slope-intercept form, and then you can adequately achieve the slope of each of the lines. That is the beauty of slope-intercept form. At a glance, you can see the slope and where it crosses the y-axis. Example 9, figure. I will go back and index, but I read it for the time, so I'm going to go back to that. What is the slope of this line? Charlie? Yes. What's the slope of the second line here? Thomas? -3. Try to take it here for what you want. But it is just -3. So the question is, now that we have both slopes, we need to compare them. Are they the same? So they're not parallel. Are they opposite reciprocal? They have to be opposite signs. We don't even have to worry about the reciprocal at this point because both of these are negative. Right? They're not the same, and they don't have opposite signs. So now we know they are neither parallel nor perpendicular. All right, example 10 is the tricky one. It's an x-only equation. X equals 10. You don't see a y there, right? There's no slope-intercept form. Y equals -2. That one is actually in slope-intercept form. It just doesn't have that x term, right? So back here, right here, we said x-only lines are vertical lines, y-only lines are horizontal, vertical and horizontal lines are perpendicular to each other. So is this a horizontal line or a vertical line? X equals 5. The vertical line. This is a vertical line. Is y equals -2 a horizontal or vertical line? Right. It's kind of the opposite of what you think at first glance because you know a y-axis goes up and down, right? And the x-axis goes left to right. That's exactly right. So this would be a vertical line through 5 on the x-axis. This would be a horizontal line through -2 on the y-axis. So they have to be perpendicular because they are one vertical and one horizontal line. Write the slope-intercept form of a line through this point, 4 -2, and parallel to this line, y equals 1 half x minus 7. What is the slope of this line here? Darren? Yeah, right here. 1 half, that's right. So now we want the equation of a line that goes through this point and has the same slope. Just use a different form of linear equation. This is point slope form. In all the forms of your linear equations in one data. Point slope form means you can see the slope and you can see one point. So when we plug in, we're going to plug in, actually I don't like that. So we're going to y minus, so remember this is the y coordinate, right? So that's negative 2 equals our slope, we said is 1 half times x minus our x coordinate. So to solve this, you don't have to write this first part, but we're identifying the slope as a given line. Then we're plugging the slope and the point that they give us into point slope form. Then we solve for y. So that's what we're going to do now. We've got a slope plugged in, and this point, y minus negative 2 is y plus 2. We're going to distribute our 1 half times x. 1 half x minus 1 half times 4 is 2. Now all we have to do is subtract 2 from both sides. And y equals 1 half x minus 4. Yes. Well, I'm trying to isolate y, right? So what's happening to y? We're adding to the y. So the only way to undo adding to is to subtract 2, right?
I thought you were trying to do it like that.
So now the equation of a line that's parallel to this point and goes through this point on the coordinate plane is this. You see the slopes are the same, but our y-intercepts are different. This one's going to go through the y-axis at negative 7. This one's going to go to the y-axis at negative 4. Any questions? All right. To finish that, I think we're getting pretty close to the end, 52. I'm going to give you kind of hints, and then we won't do example 7, just like the previous one, I think. So this is the only one we didn't do. Oh, there's another one top. All right, so for this one, it's the same thing. We're going to do the same thing. We're plugging it in, but now we need to identify the opposite reciprocal of the slope. So now the slope of our new line is going to be negative 2/7. And when we plug in here, it's minus, so this is the y, minus a negative is a plus. So we've got our slope in here, our y coordinate here, our x coordinate here. Negative times a negative is a positive. 2 times 4 is 8. 7. You can put this out over 1 if you need to make more sense to you. And now we just need to subtract the 1. And so the equation of the line that's perpendicular to this line and also goes through this point is y equals negative 2/7x plus 1/7. You don't have to do number 7. need to go over, we'll go over at the beginning of class on Monday, but I think you should be fine. Yes, I'm about to end this.